Section 5.1 is on monomials. Okay, so a monomial is an expression that is a number or a variable or a combination of numbers and variables. Monomials do not contain variables in the denominator. Variables with negative exponents are variables under radicals. So things that would be a monomial would be things like 2x cubed, or 1/2 x to the 5th y squared. Right? Mono means one, so it's just one term altogether. Or -7 a, b, c, right? It's all grouped together. It's one term. So not monomials would be like a polynomial, right? Polynomials are many terms. So something like 3x squared minus x plus 5. That's called a polynomial. Okay, but you could also have one term and it not be a monomial. That would be if you had negative exponents, like 2x to the -3. That's not a monomial because of the negative. And you can't have like 5 square root of x. So you can't have square roots. And you also can't have fractions for exponents or on the denominator. So something like that on the denominator or a fraction. So basically you can have like x's and y's, but they need to be raised to whole numbers. So 0, 1, 2, 3. All right, so you could also have a constant. A constant is just a number with no variables with it. So a constant would be like -18, right? That's a number, no variable. That would also be a monomial. The coefficient is the numerical factor of a monomial, and the degree of the monomial is the sum of the exponents of the variables. So this is a little bit confusing because, like on your 5.2 homework, I ask about polynomials. And if you talk about the degree of a polynomial, do you guys remember polynomials when you were in Algebra 1? Like 5x to the 4th minus 2x cubed. Like this would be a polynomial, something like that. The degree of a polynomial is the highest power, so it'd be x to the 4th. Okay, but the degree of a monomial, you would have to look at each individual one. So let's say I look at number 4. I look at the powers of all of them, and I add all of those powers together. So it's x squared, or y to the 6th, z to the 2nd, so 2 plus 6 plus 2 would be 10. So the degree here would be 10. So you don't add them for polynomials, you just look at each individual piece. All right, so if I have x to the 6th, its degree is 6, 14. How many x's are with that? 0, right? It's 14 times x to the 0, basically. So its degree is 0. What if you had 14x? What would its degree be? 1, right? Does that make sense? Because it's like x to the 1st. All right, the degree for this one is 3 plus 6, so it's 9. Like we said, this one's 10. And this last one is 2 plus 3 plus 9, so 5 plus 9 is 14. So you're just adding the powers. Okay, it's all one term, so all those powers kind of go together. I'm going to find out the total. All right, so a power is an expression of the form x to the n. So the example I have here is 4 to the 7th. Okay, the 4 is called the base, and the 7 is called the exponent. The whole thing together is what we call a power. Now, even I messed that up as a math teacher. Like, I still say 4 to the 7th power. You know what I'm saying? Like, it should be 4 to the exponent of 7. Right? I say 4 to the 7th power. All right, so I have 4 times 4 times 4. This is expanded form when you write it all out. Okay, so at the beginning of this this section, it's going to start out pretty easy. You're going to be like, oh, I remember this from Algebra 1. But it's going to get pretty complicated, okay? This is like the step up from Algebra 1. So let's start with the basics. I meant to give you guys a little bit of space here, too. There's a space missing. So you have 3 times 3 times 3 times 3. So it says write each expression using exponents. So this is clearly 3 to the 4th, right? The next one, 5 times 5 times 5. 5 to the 3. The next one has 5 x's, so it's x to the 5th. And the next one's kind of a combination of things. So I'm going to say it's 2 squared times 5 cubed. You can't multiply the 2's and 5's together, like the bases. You can't say it's like 10 to the 5th or anything. All right, and this last one is -3 squared times 2 cubed. That's a squared there. So -3 to the 2 times 2 to the 3. Okay, that part. Pretty good? All right, now all of these things in the little chart are all read kind of the same way, right? If I read them all as negative 2x to the fourth. Okay, but the way you read it is different than what it really looks like, what it means, right? So when I see negative 2x to the fourth for this first one, the base is the x. It's the thing that's being raised to the fourth. So in expanded form, what it really is negative 2 and then multiplied by 4 x's. So x times x times x times x. So that would be expanded form. Now that's different than this next one. This one has a base of 2x. So it's like a negative is out front, or you could put negative 1 if you really want to. And then you have 2x times 2x times 2x times 2x. And then the last one is negative 2x all raised to the fourth. So now the base is negative 2x. So now the negative is being raised to the fourth as well. So it's negative 2x times negative 2x times negative 2x times negative 2x. And all three of these are different numbers in the end, different final results. So this first one I have negative 2 times x times x times x times x. So that ends up being negative 2x to the fourth, just like it was originally. This next one, if I multiplied it out, I have 2x times 2x times 2x times 2x. That would be 16x to the fourth. But don't forget you have a negative out front, so it's negative 16x to the fourth. And this last one has the negative 2 as well. So negative 2 times negative 2 times negative 2 times negative 2 is positive 16. And then the x to the fourth. So see how they're all three different in the end. Okay, so always think what is being raised to the power. The thing right next to it or the part that's in parentheses. Okay, so I have 2 to the fifth. So what this means, so it says write in expanded form, is 2 times 2 times 2 times 2 times 2. Anybody know 2 to the fifth off the top of their head? Yeah, Alex, what is it? 32, that's correct. Some of you guys are going to get really good at doing those in your head. If you need to, like if you didn't know it was 32 right away, what a lot of people do is they group them together and they're like, oh, that's 4, and that's 4, and that's 2. So 4 times 4 times 2 gives me 32. So if you need to do a little bit at a time, that's fine. Okay, so the next one is negative 2 is the base. So it's negative 2 times negative 2 times negative 2. So I have negative 2 times negative 2 is 4, times negative 2 is negative 8. And now see how this next one's different. Now only the 2 is being raised to the fourth. The negative is just kind of hanging out in the front. So you're going to have negative, and then you're going to have 2 times 2 times 2 times 2. So it's going to be negative 16. All right, same idea on the next one. It's 1/2 x times itself 4 times. So what you're doing in your head is, like, multiplication is commutative. You can move things around. So what I'm thinking in my head is I'm thinking, well, that's just 1/2 times itself 4 times. And then it's x times itself 4 times. And then I'm finding 1/2 times itself 4 times in my head. So if I had 1/2 times 1/2, that's 1/4, right? So if I have 1/2 times 1/2 times 1/2 times 1/2, I multiply across the top and get 1. I multiply across the bottom and I get 16. And then I multiply these x's and have x to the fourth. So it's 1 over 16 x to the fourth. You could also have x to the fourth all over 16, right, if you multiply the x to the fourth in. All right, and then same thing for this one. It's negative 1/3 x times negative 1/3 x. So if you move things around, negative 1/3 times negative 1/3 is 1 over 9, and then x squared. And then this one, it's annoying to write it in expanded form, but it says to do it, so we should write it in expanded form. So I have negative 2, 1, 2, 3 a's, and 1 b. And then I have negative 5, 1 a, and then 4 b's. Running out of room. So if I move things around, if I do just the numbers, negative 2 times negative 5, I get positive 10. Then I have a times a times a, and then I have another a over here. So I have a to the fourth. And then I have a b, and I have 4 b's, so I get b to the fifth. So that's your answer. So 10a to the fourth, b to the fifth. Okay, so it's all coming back to you. You remember this from Algebra 1? Feeling good? 5.1, easy. All right, so let's try some more complicated things. Okay, so if you see a product of powers property, so it says to multiply powers with the same base, add the exponents. So if I have x to the fifth times x to the second, right, think of it in expanded form. So in your head, what you're doing is 5 x's lined up, 2 more x's on the end, you have a total of 7 x's. So it's x to the 7th. So all you're doing is you're adding 5 and 2 to give you 7. Okay, same idea if you have division. So if I have x to the 7th over x to the 4th, that would be 7 x's along the top. Let me use that. Over 4 along the bottom. And basically 4 would reduce out on top and bottom. It's like reducing fractions, like, you know, 10 over 4 is really 5 over 2, like dividing out by the same thing. That's what we're doing. So you'd end up with x cubed. So what you're doing is you're doing x to the 7 minus 4, which is x to the 3. But be careful, because you could have negative answers, right? You could have x to the negative 2. So think about that. If I had x to the 2nd over x to the 4th, that's x to the 2 minus 4, which is x to the negative 2. Okay, that's going to lead into what we're going to talk about in just a little bit. X to the negative 2 will really end up being 1 over x squared. Do you guys see that? Because of the reducing, like this idea, like reducing things out. 2 x's on top, 4 on bottom. 2 cancel on top and bottom, you have 1 over x squared. Does that make sense? Okay, powers of a power. So if I have x squared raised to the 5th, that's going to be x squared times itself 5 times. So how many x's would I have lined up if I wrote it in expanded form? Yeah, 10, exactly. X to the 10th. Does that make sense? That's a big one people mess up on. They forget to multiply. All right, power of a product. So it's saying, well, what if you have like x squared y cubed and then you raise it to the 5th? Kind of like the distributive property, right? Yeah, Basil, what do you think? Yep, x to the 10th, y to the 15th. Exactly, you take it to both of them. And same idea if you have a quotient. So let's say I have x cubed over y to the 5th, and then it's squared. X to the 6th over y to the 10th. Now, don't be crazy and try to reduce that out then. Don't be like 6 over 10 reduces down to 3 over 5, right? Don't do that. Those are powers. All right, so simplify each expression. So I have 5 cubed times 5 to the 4th. So if I wrote it in expanded form, so you don't have to do it this. I didn't say write it in expanded form. But do you guys see in your head that it would be 5 to the 7th? You guys can kind of see that. Notice how it's not like 25 to the 7th. A lot of people try that. They try to multiply the 5 times 5. It doesn't work that way, right? It's just 7 5s lined up. All right, this next one. So I have x cubed and I have x cubed. So if I lined them all up, I would have 6 x's. So I'm going to have 5 x to the 6th, y to the 4th. And then this one, do the reducing thing. So I have x cubed over x squared. So if I have 3 x's on top and only 2 x's on the bottom, 2 cancel on the top and 2 cancel on the bottom, I'm left with 1 on top, right? So it's x and then y to the 7th. And it's kind of like over 1, but we don't write that. So we just leave it as x, y to the 7th. Still feeling good? Yeah? We like this section? It does get harder. These ones aren't bad. All right, x squared y cubed raised to the 4th. So that's going to be x to the 8th, y to the 12th. You bring the 4 into both of them. Now, in something like number 5, I typically reduce first. Like, notice how there's x's on top and bottom. I would try to reduce that out before I'd raise it to the 4. And the reason is because we're going to get to really hard ones where we have like 500, x to the 8th, y to the 5th, over 100, x to the 2nd, y squared, and then raise to the 3. Like, who wants to do 500 cubed, right? Isn't it much easier to like reduce out the 500 and 100 to 5 and then cube it? Right, it's going to be a lot easier to reduce first. So that's what we're going to do. So I have x on top and I have x squared on the bottom. So if I have x over x squared, 1 cancels on top and bottom. I'm left with an x, but it's on the bottom, right? So I'm going to have y squared over x times z. And now it's raised to the 4th. So I rarely use that subtraction rule. Like, I don't like to do that one. I like to visualize in my head the x's reducing out. Does that make sense? I don't like to deal with the negatives. If I can avoid negatives, it makes my life easier.
Why not negative?
Like, you could do the x over x squared, and you could say x to the first minus, like x to the 1 minus 2, which is x to the negative 1. But then you would have an x to the negative 1 on the top, which is kind of weird. It'd be like this. And I like to avoid that if possible. What that really means is that it's x to the first on the bottom. It's x to the positive 1 on the bottom. So it gets very confusing. So I'll talk more about negatives in a second. Okay, so that's why I kind of like to think about the reducing. Okay, so this ends up being y to the 8th over x to the 4th, z to the 4th. Do you guys see how I got the 4s? Because both of these were x to the 1 and z to the 1. So when I raise it to the 4, I multiply. All right, so number 6, let's try to reduce first and then raise to the 3. So I'm going to have a squared on top, and I'm going to have a b on top. Nothing's left on the bottom, right? It's kind of like there's a 1 on the bottom. Raise to the 3, so I get a to the 6th, b to the 3rd, and that's your answer. Okay, so two strange properties. The first one is the zero exponent property. This is one that gets people every single year. Man, as much as I say it, as much as I say x to the 0 isn't 0, I still get it on the test. Just like as much as I say for the matrices chapter that 1, 2, 3, 4 squared is not 1, 4, 9, 16. Still happens every year on the test. It happened. True story. Oh yes, it happened this year. It was the first test I graded. I was like, should I just stop? Should I stop? Yeah, so it happens. All right, so x to the 0 is not 0. X to the 0 is 1. Okay, the reason is because think of like x to the 5th divided by x to the 5th. Right? If you do the subtraction rule, the 5 minus 5 thing, it's pretty obvious that it's x to the 0, right? 5 minus 5 is 0. But think about this. A number divided by itself. If I had 32 divided by 32, it's 1, right? So it's 1. So 1 has to be equal to x to the 0. Does that make sense? Because you're dividing out the same thing on top and bottom. Okay, so x to the 0 is 1. So I like to trick you a lot of times, and I like to give you a bunch of gibberish, and you're like, oh my gosh, what is all of this stuff? And then I like to be fancy, and I like to raise it to the 0. So it's equal to 1. It doesn't matter what I give you. If it's raised to 0, it's going to be 1. But notice how I did say a non-zero quantity. 0 to the 0 is undefined. It's not one or the other. You would think it would be 0. You would think it would be 1. It's not either one. It's undefined. Okay, negative exponent property. Okay, so if I have x to the negative 2, what that really means is 1 over x to the positive 2. Okay, so let's think about this. 5 to the negative 2. So every year I say this over and over and over, like a broken record. I say 5 to the negative 2 is not negative 25. And every year someone writes negative 25. 5 to the negative 2 is 1 over 5 squared, which is 1 over 25. Is it negative? No, it's not negative. Huh? Exactly. So it's never going to be negative. A negative exponent does not mean that the number is negative. Okay, so let's try this little table here. So it says fill in the following table and answer the questions on the right. So you have a little table that kind of shows you how the pattern works. So I have 2 cubed is 8, 2 squared is 4, 2 to the first is 2. So notice how each time you're dividing by 2. So as you go down, you're always dividing by 2. 2 to the 0 is 1. 2 to the negative 1 is, right, 1 over 2 to the positive 1, which is 1/2. 2 to the negative 2 is 1 over 2 squared, which is 1/4. Still following that pattern. I'm still just dividing by 2 each time. 2 to the negative 3 is 1/8, and 2 to the negative 4 is 1 over 16. So each time I'm dividing by 2. So do negative exponents mean that the number is negative? No. It is a fraction. What is any number raised to the 0 power? 1, except 0 to the 0, right? And what do you notice about 2 cubed and 2 to the negative 3? So 2 cubed is 8. 2 to the negative 3 is 1/8. They are good reciprocals. Spelling bee for math. Can you do it? All right, simplify each expression. So if I see 4 to the negative 3. Yeah. Now I'm seeing if you guys can spell it. I know how to spell it. I'm an excellent math word speller. All right, 4 to the negative 3. So it's going to be 1 over 4 cubed. All right, which is 4 times 4 times 4, 64. The next one, x to the negative 2. 1 over x squared. A lot of times on the test I say, do not leave negative exponents in your answer. So I will not accept x to the negative 2, but I will accept 1 over x squared. So know the difference. Okay, this next one's a hard one. Yuck. 1/2 raised to the negative 2. Ew. Seriously, ew. It's gross. Okay, so I'm going to show you the long way, and then I'm going to talk about a shortcut. Okay, here's the long way. If you have 1/2 raised to the negative 2, what that means is 1 over 1/2 raised to the positive 2, right? We just talked about that. 1 over. So that is 1 over 1/4, which is 1 divided by 1/4, which is 1 times the reciprocal of 1/4, so 4 over 1, which gives you 4. So 1/2 to the negative 2 gives you 4. So easier way. Take reciprocal of base and raise to positive. Okay, so basically if I have 1/2 to the negative 2, what I'm telling you that you can do is you can now take the reciprocal of the base. So you can make it 2 over 1 and raise it to the positive 2. So 2 over 1 is 2. 2 squared is 4. Done. Wasn't that much easier? Much better than that gross, ew, nasty, divide by fraction stuff. Okay, so go back to your last little table. So we're going to go back to this table here, and we're going to do one more example. So if I have 2/3 to the negative 2, I don't want to do 1 over 2/3 to the positive 2. I want to avoid the 1 over the fraction thing. So what I'm going to do is I'm going to flip the base, 3 over 2, and I'm going to raise it to the positive 2. So that way you'd get 9 over 4. So 2/3 to the negative 2 is the same as 3 over 2 to the positive 2. All right, let's try this next one. So how about number 4? Yeah, Alex? 1. Don't fall for the trap. Don't make it harder than it is. How about number 5? It is not 1. It is 2x, right? Because all of this is 1. But you still have that 2x out front. 2x times 1 is 2x. Yes, be careful. All right. See if we're up for the challenge. We got some harder stuff. All right, 2x over y raised to the negative 3. Be smart. Don't make it harder than it really is. Flip the base, right? So if we flip the base, then we can raise it to the positive 3. Now we bring the 3 in. So we get y cubed, and we definitely have x cubed on the bottom, but then time and time again, people will just write 2. It's like they forget about the poor little number. What's 2 cubed? 8. So don't forget that. So don't forget 2 cubed. All right, same idea on this next one. So we want to flip it first. So flip the whole thing. So I'm going to have b squared on top, and I'm going to have 3ab on the bottom, and it's going to be raised to the positive 2 now. Oops, that's weird too. All right. Now you can reduce out the b's if you want to before you square everything. It doesn't matter. Or you could square and then reduce. So let's say I forgot and I squared it. So I do b to the 4th over 9a squared b squared. That's when I'm like, oops, I have b's on top and the bottom. That's never going to happen. Like, you can always combine those. Okay, so what's that mean if you have 4 b's on top and 2 b's on the bottom? What happens? Yeah, you could get b to the 4th minus 2, b to the 2. Or you could imagine like 2 canceling on top and bottom. See how they're left on the top? So you would get b squared over 9a squared. That's your answer. So think about reducing. Okay, now here's where it gets hard. If you have negative exponents within the inside part, this is where it gets really, really difficult. Okay, the thing that I found that is easiest is to move locations first. Okay, so basically like you have 5x to the negative 3, x to the 5th, y cubed, and you have 15 x to the 0, y to the negative 2. If you have a negative exponent, remember what that means. Like x to the negative 3 is 1 over x cubed. And you know how like when we did that 1 divided by 1/4, how basically it became 4? It's like that whole thing just went up to the top, like the denominator. Do you guys know what I'm saying? Like it's very confusing, but things are going to move around. Like I could write this out as 1 over x cubed and continue with this fraction. But basically what happens is it just goes to the opposite location. It comes down here and becomes x to the positive 3. And this one goes up here and becomes y to the positive 2. So before I even begin, I'm going to move the negative exponents and make positive. Okay, so what I'm going to do is I'm still going to have the 5. I'm still going to have my x to the 5th and my y cubed. I'm still going to have the 15 x to the 0. But anything that was negative before now moves. So I had x to the negative 3, so that's going to be x to the 3 on the bottom. And I had y to the negative 2, and that's going to be y squared on top. They move locations. If it was on the bottom, it's now on the top. If it was on the top, it's now on the bottom. And it's still all going to be raised to the 2, like before. And I like doing this because now it's easier for me to like visualize the canceling step. So think about all of your x's. You have 5 x's on top. How many x's do you have on the bottom? 3, because x to the 0 is 1, right? That's gone. It's not really there. Like you can add your exponents and still have 3. So if I have 5 x's on top and I have 3 on the bottom, so here's what I have. 5 on top, 3 on bottom. When I reduce them out, how many are going to be left and where are they going to be left? 2 on the top. Exactly. Does that make sense? So I'm going to have x squared on top. What about my y's? Where are all my y's? They're up top. How many do I have? 5. Faisal's all over this. Got it. All right, now what about my numbers? The 5 and the 15. 1/3, just like before, right? Just like normal fractions, they still reduce out 1/3. Don't like reduce them and be like 10. That doesn't happen. Like you can't subtract them. Just like normal fractions. All right, and then it's raised to the 2. So our final answer is going to be x to the 4th, y to the 10th, all over 9. Do you guys see it? You square everything inside there. Nope, because it's 3 squared. The numbers are just going to be like just normal numbers. Yeah, don't think like multiplication or something. If it had been x cubed squared, then it would be x to the 6th. All right. Let's do one more. Super challenge. You ready for the super challenge? Let's deal with the inside first before we deal with the negative 2. Okay, so anything that's negative, I'm going to move. Okay, this is very hard for students at first because they want to move everything. Okay, anything that has a negative power, I'm going to move. So let's keep everything that doesn't have a negative power right where it is. So the 36 and 45 stay. The c cubed stays. Now let's talk about the things that move. Along the top, I had a to the negative 6. So now that's a to the 6th on the bottom. I had b to the negative 5. So that's now b to the 5 on bottom. On the bottom, I had a to the negative 5. So now that's a to the 5 on top. And I had b to the negative 3, so now it's b cubed on top. And we're going to have it all raised to the negative 2 still. So we're going to simplify as much as possible before we deal with that outside power. It gets really messy if you bring the negative 2 in, because then you'd have like 36 to the negative 2, so be careful, like if you do that. Okay. All right. How about the 36 and 45? Let's attack that first. How does it reduce? No, not 12. Smaller. What's it divisible by? 3 and bigger. Between 3 and 12. You guys know this. You're 36 and 45. What are they divisible by? 9, 4, and 5. So divide by 9, top and bottom. Okay, the C's, I just have C cubed. I don't have any more C's. How about the A's? So I have A to the 5th and I have A to the 6th. And where is it? Bottom. Do you guys see this? This is why I don't like that subtraction method, because you're left with negatives and you're like, what do I do with it now? I like to see them all positive because I like to think there's more on top or there's more on bottom. Where do I put this? So it's A to the 1st on bottom, just A. All right, and how about the B's? B cubed, B to the 5th. I have more B's on the bottom, B squared, right? It's raised to the -2.
University High School, if you order Panda Express, the meals are now in the Fairbanks Hall lobby. And if you're waiting for Panda Express food during the passing periods, please come to Fairbanks Hall lobby to get your food. Thank you.
You can go and get your food if you got Panda Express. Yes, all people watching this video, we do get Panda Express at University High School, so it's very exciting. All right, so anyway, next up. So if I have to raise to the -2, so now it's like going back to number 7, like where we started. Now what do? You flip them. So you're going to have 5ab squared on top, 4c cubed on bottom, and now it's raised to the 2. So you get 25 a squared b to the 4th over 16 c to the 6th, and that's your final answer. All right, feeling good about this? Decent? Try some homework and see how you feel. Let me pass it out.